Please make sure you enter in your scoring on the forms in the next hour-ish or couple of hours. And now I have the honor of the next little part here, which is an award that we give every year. Neil Mackenzie was a postdoctoral fellow at UBC in the Center for Blood Research, who tragically died 10 years ago in a climbing accident at Jaffe Peak. It was January 11th, 2015. Now, Neil was a wonderfully unique person. He passionately embraced life through his exploration of science and the outdoors. He infected others with his enthusiasm, his love of learning, and he was always happy to teach and encourage others. Neil completed a first postdoc in Scotland, and he flourished in that position. And he came to Canada really intending to be a climbing instructor, and he just was attracted by the mountains. Can you imagine? And when he arrived, he certainly enjoyed that, but he also sort of was still a passionate scientist, and he fell into the clutches of Dieter Brumme's lab and was enticed to do another postdoc there, where he really flourished in cardiovascular research. He was immediately recognized as a quiet, passionate leader. He was an amazing teacher. He would teach everybody around him and really just relayed his enthusiasm of science and of life to him. Now, of course, he wasn't going to give up his climbing, so he joined the Vancouver Outdoor Club. And I don't think, from what I understand, there wasn't a weekend where he wasn't found in the mountains climbing. I mean, he wasn't just climbing, but he was teaching all the beginners on how to climb and patiently offering his advice. He had an amazing sense of humor, self-deprecating, quiet, and with an amazing, charming approach. As a proud Scotsman, of course, he loved his whiskey, he loved his haggis. I'm not sure who loves haggis, but he loved his haggis. He was an avid music fan, and particularly of hip hop and bluegrass. And with all these talents and interests, his housemates describe him still as a very modest person with a bright and bubbly personality. So since our loss of him, we've recognized his mentorship qualities in all these fields annually with a prestigious award. And this year, and the award is adjudicated. We have many nominees, but the competition is adjudicated by mostly many of his friends from the Vancouver Outdoor Club, and then others in the CBR who knew him. And this year, I'll just skip this slide. The awardee is Dr. Michael Sutherland. Michael, I hope you're here. Michael is well known to all of us, certainly at the CBR. He's been around forever. First as a research associate of Ed Prysdale in his lab, and then he's sort of moved up the ranks, but he's always there for everybody. He's in earlier than everybody, even than me. Michael, congratulations. Speech?
Yes.
Okay, you have 20 minutes.
Yeah, I know.
Okay.
No, I don't. I purposely sat at the back of the room just to kill some time, knowing that Ed really likes to keep these functions on time. So I'll do what I can to keep it short and sweet. Just an outline of what I'm going to say today. Sorry. So I'll start with some thank yous, then give you a little bit of background of where I came from. And then finally give you some gems about how I approach mentorship. So here we go. Ed said I've been around for a while. I have been around for a while. And I think this story is really a lifetime in the making because I've been with my supervisor for 30 years. Anybody been alive that long? I would venture that the first 3 rows over here aren't even that old. Yeah, so this story is a lifetime. And it's a good story, I think. So thank you. Thank you to the CBR. The staff from the CBR are amazing. And they really do support trainees, and mentors. And they do it through a whole series of scholarships, things like that. These events are really amazing to get people together and start talking, and just really valuing, really the trainees and the people who work at the CBR. So thanks to the CBR for fundraising and support. And then thank you to the committee. I actually never knew who made up the committee, but now I know. So thanks to the Neil Mackenzie Mentorship Excellence Award Committee for selecting me. The pool of people for this award is amazing. I really would like to congratulate all of the nominees. It's really hard to look at my face when I'm doing this. I know you guys have to look at me, but I don't want to look at myself. So it's really, just recognizing the fellow nominees is amazing. There's a huge amount of people that really care, and that's good to see. And it's also good to be nominated. Feels really good. That picture of Neil, I was around, obviously, since I've been here for 30 years. I was around when Neil was here. And I didn't know him personally, but that picture really exemplifies what I remember of Neil. He was always smiling. He was always involved, always around, and very approachable. Unfortunately, I didn't take that opportunity to meet him personally. Okay, so that's the first part. 30 years with Ed. So here we go. I would like to acknowledge and thanks Ed for taking me on 30 years ago. Yeah, it's a long time. And for those of you who don't know, Ed is a CBS scientist, so I've actually been supported, thankfully, by CBS for the last 30 years. And that's a rarity. So I want to acknowledge them. He really took a chance on me, and I appreciate that. Oh, yeah, and this is where I actually learned the holy trinity of science in our lab. The 3 things that we need in our lab is controls in our experiments, mixing, and math. So those are the 3 things I learned. So keep those in mind. Those will get you forward in science. So always put a control in your experiment, always mix your reagents properly, and if it goes wrong, first thing to do is check math. So those are the 3 things. I'll have little pearls of wisdom throughout this, so you might want to write this stuff down. So those are the 3 things I learned in his lab. As well, the CBS as an organization at that time was really, and still does today, really fosters and develop research and development, it was called at that time. And I also like to acknowledge 2 other people from CBS. First one, obviously, is Dana. Second one is Bill Sheffield, who is in Hamilton, but they've always been there and approachable as well. Okay, so that's that. Who was my mentor to begin with, other than Ed? Because you all know PIs just sit in their offices and everybody else does the work, right? So who is my mentor? Her name is Tina. She was straightforward, you knew what you had to do, and she expected you to do it. And I think that's kind of what I do as well. So she set me up really early to keep going and really put time and effort into science and doing your experiments to make sure you get the best outcome that you can. So thanks to Tina. So if you notice, sorry, I should have explained this at the beginning. There's sort of a theme to this. So I'm going to do some thank yous first, hierarchical arranged. So the next one I would like to thank and acknowledge our colleagues. So over the years, there's been a lot of people I've interacted with in the CBR, mostly. So just thinking about those people. Making relationships with the people you work with are important. You want to think because you're spending a lot of your time with those people. So making personal connections with people you work with is really important. They are your support system. They do help get you through. And you can rely on them for shared experiences, which is really valuable. So acknowledging those people that got me through, there's a lot that I've known. Some of them are still here. Most are gone. Yeah. Who else? Okay, so one I do want to thank or acknowledge, because he told me to this morning in a text, is Scott Mixner. We spent probably 15 years together upstairs. He was my ride or die, so it was fun. He's gone to farm. He figured things out early and is now raising ducks on Vancouver Island. So he's my spirit animal, so thanks to Scott. Yeah, so we have colleagues, and now the next one are the current and past students in our lab. So again, there's been a lot of people go through. Each student we have is unique and diverse and requires a different skill set to help out and let them achieve their goals. So yeah, so really like to thank them. Obviously the present and past students in the lab for nominating me. I assume it was them who nominated me. I don't really know. We didn't have the conversation because I didn't want to talk to them. Because I've known this for a couple of weeks and in my face, I can't lie. So had they asked me before this, I would have cracked, but didn't want to let them know. So thanks for nominating me. And it's really important to make strong connections with the students as well. And, you know, both scientifically and socially, and just trying to keep it as light as possible, because it's really hard sometimes to work in the lab, you know. So most of our communications are based on song lyrics, stuff like that, social media stuff. Yeah, so when Caitlin first let me know about this, and then I talked to Ed about making slides or whatever, you know, they said just talk about being a mentor. And really, you know what? It was hard. It was hard to figure out what to do. And, you know, don't ask me how I did it. I just did it. It was hard. Yeah. The front three rows got that reference. The back rows didn't get that reference so much. So yeah, and having to know that, I had to fact check some of the things I'm about to say because some of our conversations in the lab do revolve around social media. So I was told that I don't have a lot of riz, which is short for charisma. That's what I thought, and luckily I wrote that I was going to say it, and then I had to fact check. So I went online today and typed in, is riz offensive? And then, of course, the first reference that came up was Reddit, which is not peer reviewed at all. But they said no, and I quote, "This question is cringe." So I stopped there because that was not a good way to go. Yeah, so that's got us here to right now. So my approach to mentoring is three prongs. I'll do that. So the first one is feedback should be immediate and actionable. So you want to, you know, if something's going wrong, if something's going right, let them know right away so they can understand what's happening, and then give them some suggestions to make it actionable. So you can't just say that didn't work, try it again. You have to offer some solutions or offer some ideas, things to change. So first one, feedback is limited and actionable. Second one, manifest success. So that means think about your experiments, think about what you're doing, and what has to happen for that experiment to occur. So obviously thinking about all your reagents, putting it all together, timeline, if you're tired, if you're got a meeting to go to, if you have to run off, obviously you don't want to start an experiment and then have to leave it. So manifest success. So plan each step out and then you're better equipped for it to work out. And then my approach really has changed to a lens of diversity. So realizing that the students coming in now, all y'all, are really diverse. And that can mean a lot of things, but we have to really celebrate that diversity. So that's important. What I do for that, everyone has different lived experiences. So just checking in with them is easy in the morning. Just say, hey, how are you doing? And don't let them go directly into science. Ask them how they're doing and really value what they give back to you. And then, go from there. Yeah, students are people too. So we have to remember that. So yeah, and that could change from day to day and things like that, because obviously everybody's busy. There's a lot of stressors out there now. So we really have to check in more and just value what's been said. So coming to a close, I wanted to keep with the social media sort of thing to close. There's something about an apple dance and brat summer. And then I was like, hey, why don't I do that? Like, let me do a self-check here. Let me go back and do my own feedback. So I was like, hey, that is not actionable. I am not doing that. As well, I can't manifest success by doing the apple dance, because that's not going to work. It's going to look terrible. So I was like, no, self-check, not going to do that. So I'm going to leave you with this. It's been, I'm extremely grateful to be nominated and humbled to receive the award.
Thank you, Michael. Okay, we're going to just move on to our, whoops. I'll just skip that. To our keynote speaker. Where's our keynote speaker? Hi, Brianne. So Dr. Brianne Kent is an assistant professor in the Department of Psychology, Canada Research Chair in Tier 2 in Translational Neuroscience and Dementia, and a Michael Smith Foundation for Health Research Scholar. She started off at SFU, at Simon Fraser University, where she did her Bachelor of Arts. Went to Yale, where she did a Master's of Science and Master's in Philosophy. She then went to the University of Cambridge in the UK to do her PhD, and there where she was a Gates Cambridge Scholar. She returned to Vancouver, to UBC as with a Banting Postdoc Fellowship for a postdoc, and as well as a Michael Smith Trainee Award and an Isaac Walton Killiman Award. And then did also a sleep medicine certificate as a postdoc at Harvard Medical School. Her research program examines the processes underlying cognition, circadian rhythms, and neurodegenerative diseases in rodents and in humans. She's an open science advocate, a member of the CIHR Governing Council, and the Associate Director of the SFU Institute for Neuroscience and Neurotechnology. And we are really, really pleased that she came all the way from Simon Fraser to talk to us today.
Hi, everyone. Thank you very much for that warm welcome. And it's really great to be here. Bravo to the students. I really enjoyed your presentations. They were really fantastic. It's amazing to see the breadth of research that's happening in the Institute out here. So today I'll tell you about our work investigating sleep disturbances as a risk factor and therapeutic target for dementia. As a bit of an overview, I'll introduce Alzheimer's disease and why we're interested in sleep. And then I'll go into a few research questions. The first is, if sleep is a therapeutic target for the disease, then what aspect of sleep should we be targeting with therapeutics? The second question is, what cognitive tasks should we be using? Because ultimately, for any clinical trial focused on Alzheimer's disease or other types of dementias, we want to improve cognition, or we want to at least measure memory and different cognitive aspects to see if we're able to slow decline. So it's really important to be using the right tasks. And then I'll just briefly mention a study, just because it's a collaboration with some UBC researchers, looking at post-traumatic brain injury sleep and whether or not we should be focusing on that aspect when trying to prevent later neurodegenerative diseases after concussion or traumatic brain injuries. So Alzheimer's disease is the most common cause of dementia. It has 3 neuropathological hallmarks. The first is the neurodegeneration. So we see a physical shrinking of the brain, enlargement of ventricles when we look at a CT scan or an MRI. We see amyloid beta plaques, which is this extracellular deposit of beta amyloid. And then we see tau tangles, so intraneuronal accumulation of hyperphosphorylated tau, which leads to neural dysfunction and then the neurodegeneration. Now, the way that we think about Alzheimer's disease has really changed. When I was a student, I was told, and it was true at the time, you could only diagnose Alzheimer's disease at autopsy. But over the last decade or so, with the great developments in biomarkers, we're now able to see disease processes in individuals who are still alive. We can measure the amyloid beta, we can measure the tau in cerebral spinal fluid, and we also have PET neurotracing for neuroimaging, where we can actually visualize the spread of this amyloid plaques and the tau pathologies in the brain. Now, from these biomarkers, and also from some really some of my favorite research that's happening around the globe, is following these families that have these familial genetic variants that cause Alzheimer's disease. And in these families, if you know someone's a carrier, you can estimate the age of onset. So looking at these biomarkers, you can look early in the disease processes, well before any of the dementia occurs, and you know approximately how far along they are in their disease processes. So for example, you could have a 20-year-old carrier, you know that your estimated age of onset of dementia is 50 years of age. So they're 30 years before the onset of estimated dementia. And so you can use these biomarkers now, and we now know that these processes are developing for decades prior to dementia. So instead of thinking about Alzheimer's disease as just the dementia, we now think of it as the disease process happening in this prodromal stage that can happen on average for about 22 years. They're having the amyloid develop before the dementia. So a lot of the research with Alzheimer's disease specifically is focused on this part of the disease, this prodromal asymptomatic stage, to say, how can we identify individuals in this disease state? Because we're not going to give everybody a PET image, right? We're not going to put everyone in the scanner. We just can't. So how can we identify people in this stage in other ways? And how can we slow this? Because with these age-related diseases, if you slow the disease processes enough, you're essentially preventing it. So how can we change the slope of this progression and slow it down in these individuals? So why are we looking at sleep? Well, we've always known that individuals with Alzheimer's disease have very disrupted sleep patterns, and it was always thought of as a symptom of the disease. It's even reported as the #1 reason why families end up putting their loved ones into a care facility, is because their nighttime sleep disruptions are so disruptive to the families and the caregivers. If you were to bring a cohort of individuals, of patients that were diagnosed with Alzheimer's disease, approximately 60% would meet the clinical diagnostic criteria of a sleep disorder. Most often it's obstructive sleep apnea. They present at a 5 times higher rate than others. But for most patients, you're going to see sleep fragmentation, where they're waking up several times throughout the night. You're going to see napping during the day. So this day-night rhythm is completely off. And when you look at specific sleep stages to figure out what aspects of sleep are disrupted, it's quite often seen that it's the slow wave sleep, which is the N3 stage of sleep, which is your deepest. So it's the hardest stage to wake you up from, and it's referred to as the most restorative stage. And also REM sleep. So that's rapid eye movement sleep, when you have your most vivid dreams. So why is sleep so interesting? Well, we've always known that it was a symptom of dementia, but over the last little while, there's growing evidence that the sleep disturbances happen early in the disease progression, prior to the dementia, and also are contributing to the disease progression. So it's referred to as this bidirectional relationship, where sleep disruption, sleep disorders can lead to a greater progression of the disease, but also that the disease then can lead to more sleep disruptions. And it's been estimated that 15% of cases of Alzheimer's disease could potentially be prevented if we treat the sleep disorders. So 15% might not seem like a huge amount, but when you consider that there are 50 million people around the world with dementia, it's millions of people who we could prevent from getting dementia if we can identify those who would benefit from interventions targeting sleep, and if we target them early. So if you were to follow cognitively normal elderly individuals, so individuals who don't have mild cognitive impairment, don't have dementia, have no reported cognitive impairment, and then you follow them, you'll find that those with sleep disturbances, either from subjective reports or objective measuring, have a faster rate of cognitive decline and a higher risk of developing dementia. If you were to then use those biomarkers that I spoke about in these individuals who, again, have no symptoms of dementia, those that have sleep disturbances are much more likely to be biomarker positive for these Alzheimer's markers. So have higher levels of, well, lower levels of the amyloid in the cerebrospinal fluid, which is indicative of higher levels in the brain, and then higher levels of the PET biomarker tracers for the tau and the amyloid. And most interestingly, there is evidence from both humans and mouse models that by manipulating sleep, you can directly affect the production of the amyloid beta and also the clearance. Anyone who's been following the space might have seen a paper that came out, I guess about a month ago now, kind of adding debate to whether or not this clearance really is happening at a higher rate during sleep, but there's substantial evidence that there is. So anyway, it's a space to watch and see how the science unfolds there. Oh, I'll just point out that this is an image of a transgenic mouse model of Alzheimer's disease. Having them go under sleep restriction for 6 to 8 weeks increases the plaque load in the brain. So the first research question that we're looking at in my lab is, so if sleep is a therapeutic target, what aspect of sleep should we be targeting? So sleep is a very dynamic process. We have multiple stages of sleep, and there's different characteristics in sleep that we could be targeting. You might have heard of sleep spindles. It's really important for motor learning, K-complexes, non-REM, REM. So it's not as simple as just saying, have somebody sleep more, and then hopefully we'll get the benefits. We're really interested in what should we be targeting. So to answer that question, while I was at UBC, working with Hawk and Nygaard, we phenotyped 4 different Alzheimer's mouse models. So these are transgenic models. And we found in 3 of the 4 models a reduction in slow wave oscillations when looking at the EEG recordings of them during sleep. So we didn't see necessarily a reduction in total sleep, but what we found was this shift of the power spectra. So the slow wave oscillations that are associated with your deepest sleep were reduced in 3 of the 4 mouse models. And anyone who's worked with transgenic mouse models knows that if you're seeing the same phenotype in 3 of 4 models, that's something that you're probably onto something, because it's very hard to replicate phenotypes, at least in these dementia models. So we moved on to studying the same processes in clinical patients. So we worked with a company called Cognionics, developing a headband that would be comfortable for individuals, for older individuals, to record their sleep in the home environment. This is really important because bringing individuals with dementia into a sleep clinic, they're very prone to delirium when bringing into the hospital setting for overnight visits. So it's really difficult to monitor and understand sleep in this patient population. So it was really important for us to be able to monitor them in their home environment. And what we found was when we gave this headband to individuals with mild to moderate Alzheimer's disease, so the dementia had already started, we found a specific reduction in N3 sleep, which is the slow wave sleep. So very similar to what we were seeing in the mouse models that we had phenotyped. So the next question is, okay, if we're seeing this in our transgenic mice and we're seeing this in a patient population, the specific reduction in slow wave sleep, and specifically this shift of the power spectra, how can we target slow wave sleep? So in my lab, we tried optogenetics and it didn't really work. So we moved over to pharmacological manipulations, and I'm working with a really talented honor student, Mayuko, studying this drug called trazodone. So trazodone was an antidepressant that's been on the market for decades, but recently it's really just prescribed off-label as a sleep aid for individuals who have insomnia or sleep difficulties. It's safe in elderly, and it's often prescribed in elderly patients. And what's interesting about trazodone is it specifically increases the amount of slow wave sleep. So it's really a great sleep aid in that we think it really kind of promotes the most restorative stages of sleep compared to other sleep aids, which can be more sedative and not really promoting what we consider a natural state of sleep. And why trazodone is also interesting is because the University of California, San Francisco Memory Clinic did a retrospective analysis, and they found that the individuals who were on trazodone actually had a slower rate of cognitive decline when they looked back through their records. There's very little preclinical research on trazodone in mice. It was a surprising limit. There was one study that looked at a frontotemporal dementia model. It's a tauopathy very similar to Alzheimer's disease, and they did find reduced tauopathy from trazodone. But digging into this space, we found that why there's so little research in mice trying to model these effects of trazodone is it's actually very difficult to administer to mice in this type of sleep research. You can't use oral gavage when you have the EEG headsets, and you can't inject trazodone without changing it because it only dissolves at a very acidic level. And so actually administering trazodone to mice turned out to be a really big challenge that we weren't expecting. But we developed this voluntary oral protocol with Mayuko and found a very beautiful dose-dependent relationship between the amount of trazodone that we were administering and this increase in slow wave sleep or non-REM sleep. And it shifts the power spectrum in the opposite direction of what we normally see in our mice. What was surprising about our findings is that instead of it just being an increase of the stage of sleep that we wanted and a less wake, we're actually seeing a reduction in REM sleep, which is something we weren't expecting, and it is a little bit concerning, just because REM sleep is also known to be important for brain health, important for different aspects of cognition. So we're following up with that. What we've done now, this was all in wild-type mice. We've now administered trazodone for 60 days in our Alzheimer's mouse model, showing consistent effects on sleep even after 60 days of this voluntary oral administration protocol. And the next step is to look at, which is ongoing right now, is the effects on neuropathology in the mouse model of Alzheimer's disease and also cognition. So that brings me to my next research question. If we're manipulating sleep, what should we be using as clinical trial outcome measures? So what aspects of cognition are going to be most sensitive to these sleeps, whether it's sleep disruption or sleep aids, but what are the cognitive tests that we should be using? Not all aspects of cognition are sensitive to sleep disruption or affected by sleep. So in my lab, I just want to turn this. There we go. We use touchscreen cognitive testing. So my lab is really focused on translation and shrinking the translational gap. Decades of Alzheimer's research and failed clinical trials until most recently, you would see these cures in the mice that were never translated to actual impact in the clinic and effective therapeutics. So the way that we design the work in my lab is we're trying to use the same types of methods in the rodents and in the humans, and especially around cognition. So we use touchscreen cognitive testing in both our mice and our human participants. You can see here, this mouse is getting rewarded by strawberry milkshake to go up and press the right stimuli with its nose, a nose poke, on the screen. What's great about this platform is others have shown that individuals who have a disease diagnosis or carry a specific familial mutation, and then you have a mouse who has that same familial genetic variant, they can show the same kinds of deficits on tasks that are designed to be the same for the mice and the humans. And also with therapeutics, you can see a benefit in the human patient, and you can see a benefit in the transgenic mouse model as they're performing very similar tasks. So it's really focused on a translation. So the aspect of cognition that we hypothesized was going to be most sensitive to these sleep manipulations is a concept called pattern separation. So pattern separation is a computational mechanism which basically enables overlapping experiences to be stored as separate representations as memories. This is really important for episodic memory, because so much of your daily life, as you're remembering the episodes of your life, involve the same people, the same environments, the same things. So keeping these types of episodes that have so much overlapping information separate as distinct memories is really important, and this process is important for that. In Alzheimer's disease, it's episodic memory that is most vulnerable. So what my students Ina and Devin did is we recruited younger adults and we recruited older adults, and we monitored their sleep in the home environment for a week. And then we brought them into the lab and we did a variety of different cognitive tests, which included tests that were very designed to assess pattern separation. And what we found was that indeed these tests that were designed to assess pattern separation did show a relationship with the amount of sleep that the individuals were getting. The more sleep the older adults were getting, the better they performed on these specific tasks. Performance on these tasks also correlated with the MoCA score. So this is the Montreal Cognitive Assessment, which we often use as part of the diagnosis in dementia. So we use that clinically. Next, my students brought in university students, so younger adults, for a sleep deprivation study to see if 24 hours of sleep deprivation also showed an impact on performance on these specific tasks. And they did find the same relationships, where those tasks that are designed to assess pattern separation did show performance deficits after 24-hour sleep deprivation. That was what we learned. I also learned how little undergraduates sleep. So of the 35 rested subjects who went home and slept, I think only 6 of them got at least 7 hours of sleep, which is the recommended amount. It was shocking to see how many students were getting 3 or 4 hours when we said, please go home and have a good night's rest. So students, please sleep. It's good for your brain health. It's good for your academic success. Sleep is important. It was really, really shocking. So in mice, we can study the same process of pattern separation using a task called tunnel. So here we're able to separate the spatial locations of stimuli. The mice are trained with strawberry milkshake to go to the new location. And you can vary how similar the locations are as a way to kind of tap into this process of pattern separation. The closer the stimuli are, the new location from the old location, the harder it is to discriminate. And the more this process of pattern separation is required. So what we've done with this task, we did a study with just wild type mice looking at sleep fragmentation for 6 days. We only did 4 hours of fragmentation a day to be really similar to what we were doing in the humans, and it found we did not see an effect on performance. We did learn in that process, which I'm not going to go into today, that actually the screens that we're using are causing circadian entrainment to the mice. So doing this kind of work with these screens is having additional challenges, which I have a master's student who's working on right now, and we can change the colors of the screen and the brightness, and it'll be fine. But it was a funny finding, not what we were expecting. That kind of takes your research in another direction. So for students here, it does happen where you can learn something, have a strange observation in a study, and it can take you in a different direction. But what we're doing now with Tunnel, I have an incoming master's student who just finished his honors on this project, where he was comparing the effects of sleep fragmentation, which is what we see in the older adults, and sleep deprivation to try and see whether or not we were getting effects on hippocampal neurogenesis. So hippocampal neurogenesis is the production of new neurons in the hippocampus, which continues throughout life. It's one of the only areas of the brain that continues to produce these new neurons, and there's conflicting evidence about what role they play in cognition, but this process of pattern separation seems to be key for these highly plastic new neurons. So what Robert's done is he compared the sleep fragmentation to sleep deprivation to try and understand how much of this sleep fragmentation or how much of this deprivation do we need to get performance effects on the tasks, the tunnel task that we're using. He's also the one who's going to be doing, with the tunnel task, looking at the benefits of trazodone to see if we're getting any cognitive improvements. So that is ongoing work. So finally, just very briefly, a study that we're working on in collaboration with Cheryl Wellington's lab here at UBC is looking at traumatic brain injury in mice, so specifically repeated concussions, and to see whether or not post-concussion sleep is a therapeutic target to prevent the neurodegeneration. So you may remember Will Smith's movie, you might be too young to remember Will Smith's movie, or the New York Times headlines that NHL players, NFL players, this high contact sport athletes are at a much higher risk of developing neurodegenerative disease and dementias later in life. And so what we're trying to do in the lab is model that. One of the biggest complaints of individuals who have a concussion or who've had a severe traumatic brain injury is that they don't sleep. They either sleep too much after their concussion or they suffer from insomnia. So sleep is one of the top complaints of individuals who have a concussion. What we're doing with the Wellington lab is we're using their device called Chimera, which allows us, it's a model of concussion that's really focused on translation. So it's a closed head injury model of concussion, like an athlete would have, or quite often in a car accident, where you don't actually open the skull, which is what a lot of the traditional mouse models would use. This allows a closed head injury, and it also allows the rotational force. So it allows that head spin that you get when you are in a car accident or as an athlete, whereas a lot of the other models would hold the head very securely and not allow that rotational force to be happening to model concussion. And so what we've done in this mouse model, 2 mouse models of Alzheimer's disease, is we've used their Chimera device, and we've confirmed that yes, indeed, the traumatic brain injury, repeated concussions are damaging neurons. So we measured neurofilament light. That's some of the only blood sampling that we do in my research, given that we're at a blood institute. And we've shown that it does increase the rate and the amount of plaque pathology in the mice. We have not replicated the effects on sleep that we see in the patient population in our mice. So we're not seeing an increase, we're not seeing a decrease in sleep. We are seeing some things when we're also looking at epilepsy, and there is some sleep-dependent stage on seizure activity post-traumatic brain injury, but we're not replicating the hypersomnia or the insomnia in the work that we've done so far. So I'll just say thank you. I forgot to do a summary slide. I forgot to post it. So I will just say, as a bit of a summary, the type of, the aspect of sleep that we think is most important and that we should be targeting with potential therapeutics for Alzheimer's disease is slow wave sleep. And in terms of the cognitive tasks that are designed to assess pattern separation seem to be most sensitive to sleep disruption and potentially sleep aids. And I'd like to say thank you to my students and thank you to the funders, and I'm happy to answer any questions that you might have.
And yes, are there any questions? Maybe oh, Ed, go ahead. Should I know?
Thank you, Kevin. Thanks very much for that. It was really interesting. I remember reading someplace about a very small population of a very small part of the population that are classified as elite sleepers.
Elite sleepers.
And do you know about this?
No.
Oh, okay. Well, then maybe I won't ask you about the question. I'm just remembering that this is a population that is perfectly happy living on 5 or 6 hours of
yes.
sleep.
Yes, I didn't know the
And this was
terminology.
correlated with 2 or 3, maybe 4 gene mutations that might have been linked to lower plaque formation. And I'm wondering whether you have learned anything about this and whether there's been further correlations with later life development of AD.
No, I haven't seen the research on the elite sleepers and the plaque pathology, but I'll definitely be looking into this after. I often get asked about individuals who are perfectly fine sleeping for 4 or 5 hours. They seem perfectly fine. And I would definitely say Matthew Walker is a big speaker and proponent of sleep. He's written books and a lot of people hear what he says about sleep. I disagree with him a little bit in that if you sleep for 4 or 5 hours and feel totally fine, you probably only need 4 to 5 hours. Because like with everything in biology, it's a spectrum, right? You're gonna have some people who really need 10 hours of sleep a night. They exist and they're perfectly fine. That's their biology. And you have some people who only need 5 hours of sleep and that's what they need. So it's a spectrum, right, with everything in biology. But no, I don't know about these specific sleepers who also have a lower plaque load, but I'm definitely interested in it.
I think Conway's an elite sleeper. We got to get some blood sampling done.
I have a question. Obstructive sleep apnea.
Yes.
Very common.
Yes.
Snoring is very common, but obstructive sleep apnea.
Yeah.
The CPAP business is booming, I'm sure. It's probably, though, underdiagnosed, I would expect, because usually snoring initiates CPAP referral, sleep app, because the partner wants them to,
Yeah.
or they're really functioning badly, which is relatively in the minority. So what's the relationship to dementia or cognitive dysfunction, and should we be screening?
So we should be screening for sleep apnea and we should be treating sleep apnea. But the biggest issue, because they have shown that CPAP use can slow cognitive decline in individuals who have sleep apnea in the older population in the dementia space. The biggest problem is compliance. So when you look at those studies, when you actually look at how many people dropped out of the study or just the non-compliance with CPAP, if people were to use CPAP, it's great. People don't want to use CPAP. So we really need new interventions to treat sleep apnea. It's very treatable if people just used CPAP, but they don't want to use it. Yeah, it's an uncomfortable system.
It's also not covered.
Here?
The machine, yeah, the equipment isn't covered unless you have extended insurance.
Okay.
Yeah.
Well, it should be covered.
It should be covered,
But or something that will actually, people will use.
Karen.
Hello, thank you very much for your presentation. Is there anything we can learn from penguins? There was a science paper that came out about penguins and microsleep, that they sleep for very short periods of time. Do they get dementia?
I don't know if penguins get dementia. I mean, one of the problems with mice and rats is they don't naturally develop dementia. So we're giving them these transgenes and trying to do a purely genetic form of the disease in these mice and trying to get them to have dementia. Dogs get dementia. I have no idea if penguins get dementia. How cool. No one has probably studied dementia in penguins.
Any others? We'll have lots of time after. Okay, but I do want to thank you very much.
Thank you.
Got it?
Thank you.
This is-
Oh, wow. Thank you.
Okay, thank you very much.
Thank you.
All right, so we're wrapping up. All right, so posters and poster judging and open bar is next. First though, thank yous to our sponsors once again. Thanks to the supervisors, to the research associates, the technicians, the anybody involved in working with students, summer students. I know that it's hugely appreciated. To the organizers from the LSI, from the CBR, and we thank you. Don't forget to vote for your favorite oral presenter, and also there'll be a feedback. You'll probably receive something from Caitlin in the very near future. The posters are out there, the food, there'll be food and drinks out there. I think there's poster judges, they're all lined up. So thank you very much.